Hi there! For all of you who are following my YouTube channel, you may know that we already worked here on this Alinco DR-570. So if not, you can watch video 172, and we diagnosed a problem here in our output stage, so we fixed it, and the radio after that was transmitting again. But then additional to that, we had a receive problem on 2 meter, and we have taken out the PCB, and we tried to fix or to test, let me call it that way, the obvious points, so diodes and what have we, but we were not really able to go ahead, since it was not easily possible to test here underneath the PCB. So normally, you know, the PCB is here in the chassis, and we really do not have a chance to get under. And we run out of budget, and so we had to stop the job. But you know, the owner really loves his old Alinco, and he said, "Hey, I really want to get it back, so please can you try and fix the receiver problem as well? It is such a nice radio." Okay, so what can I say? I agreed, and okay, so we are now prepared to troubleshoot the problem, and you see I have already the PCB upside, so that we can go underneath, and therefore you can see it. So we built here some extender, so that we are able to connect finally the PCB to almost it is almost here to the PA board, and that way we are able to finally run the radio and troubleshoot our problem. So that is so far our status, and when we did the first video, so the 172, we tested the radio, and we found that the receiver is not very sensitive, and that is now the status where we start or dive into the issue. Let me go over to our tester. Yeah, and the radio is already switched on, and of course it is on receive, and you see that we are here sending on the frequency, which is of course dialed in the radio, and we are sending here with minus 74 dBm, and you may know that on ultra shortwave with minus 93 we should already achieve an S9 level, but with a much higher input level we only have noise. And we found already in our first video that we really have to increase our input level a lot, and now you may hear it. So we get a signal, and we see here it a little bit on our screen here, but it is still very, very noisy, and that with minus 37 dBm. And if you work with radios, you know that minus 37 is really high power into the front end of our radio. And if I go back here to, you see already with minus 56, which is still a very strong signal, So if we go, for instance, to minus 53, so that is 20 dB over an S9 level, so that is S9 plus 20 dB, and yeah, noise, nothing than noise, and that means we really have here a sensitivity problem, and that is what we need to troubleshoot. So therefore, let me go back to I don't know. So let's go for a relatively strong signal. So let me set the radio to minus 40 dBm, and in the background we already hear again that there is a little signal in the background, and with minus 40 dBm let us now hunt here our problem. And a quick look here onto our schematic will help to understand what will be our next steps. So what we have here, so this is our signal input, and then we go over this diode pack here, our D3, right here into our dual gate MOSFET or FET. I'm not sure if it is a MOSFET. It might be a normal FET. Anyways, it is a double gate FET, and yeah, so what we want to try is we check if we find our input level here at the input, and then we want to follow here along until we get here to the input to Q1, and of course we will try and follow here the signal until to Q2, and yeah, we want to see if we are really losing here somewhere on this trace our signal, and yeah, then therefore let us go step by step right from the beginning. And here is now our PCB, and we want to orientate here on our PCB, and let's see how far I can zoom in. But yeah, maybe I'm already able to show you where we want to start. Yeah, we have here our input signal, which comes over our PA board, and it really goes through our D3. So let's see if we get a better view. Yeah, so there you see our double pack here, our D3, and we see here our Q1, which is the dual gate, and then when we go over, then we find of course here our Q2, and that will now be our first step. We start right at the input and follow along and see what we can find so far. Okay, and we really go ahead here with our spectrum display. I try, I hope it is possible here around the camera. So I now try to touch here the input, and we already see I have already a problem here to let me see that I can get it here a little bit better. I have to reposition the camera a little bit. Okay, so let's try again. I hope I will be able to do it here around the camera. So now, yeah, it is pretty nice. So now I am directly at the diode input, and you see we are really able to pick here our -40 dBm, and that is telling me that the signal is really getting to this point. And now I just want to try to pick the same signal behind our diode, and you see behind our diode we already have a real loss, and that is already not very nice. Also we know that the diode is fine, because the diode has been tested last time, and we found that the diode itself is you know, without any problems. So what we can do next is to test at the gate of our dual gate FET. Okay, so let me go to our gate 1, and let's see what we have there. And oh yeah, so you see we have a signal, but compared to the input level, we should have, or we know that we have -40 dBm, and now we are here creeping at -90, and you see how much level we already losing here, you know, at the first portion of our input part. So let's have a look back in the schematic to think about our next step. Yeah, and again, so here at the anode of the D3 dual pack, we have our -40 dBm, just fine. And here at you know, the cathode, we have already lost a huge amount of signal strength. And then if we follow here along, you see that now here at the input we have -90 dBm. And well, you know, that is definitely too much attenuation here on the first portion. And there are definitely different possibilities why it is that way, and one could already be the fact that maybe here our bias voltage for the diodes are missing. So we know that we need to bias our diode, otherwise it is not so easy to get a signal over. And then what is with, you know, our DC level on our second gate here on Q1, and additional to that, I'm really curious if we have supply voltage for our FET in general. So I would say let us test that first before we go ahead. Okay. Okay, so everything is prepared that I can now pick here my voltages at the different points what we have already discussed before. And additional to that, here coming back to our schematic, we see here that where is it here? So that is our receive voltage of 5 volt. So if we check the input, we should see our 5 volt, which is the supply voltage for receive. And well, we really can start directly there. So that is, if you like, the switching voltage, where we want to start here. Where is it? If we have here our supply or our bias voltage. So this is coming from the 5 volt line, and of course here at drain of our FET we should be able to read 7.1 volt, and that is of course coming from, I believe, a 9 volt line, or 8 volt. I'm not entirely sure, but anyways, so that are the voltages we should be able to see. Okay, so first let me check here the 5 volt, our receiving switching voltage, if you like, at the input connector, if that is present here towards our board. And yeah, 5.1 volt, so no problem, that is just fine. So now let us check the voltage directly at the input, so that means the anode of our D3 package. So that is what we want to see. So let me go down to that test point, and yeah, we have 4.8 volt at the anode. And now I'm interested what will be the voltage at the cathode. And we know if we see a drop between 0.3 and 0.8, then that would be fine. And now I'm at the cathode, 4.58, so output, if you like, and input it is 4.85, so that is 0.3 volt drop over our diode. So that means that our diode is biased in the right way. Now let me go to the gate 2, where we should read the voltage for amplification, and that should be here. There is definitely nothing, so that is all in 146 millivolt, so that is definitely too low. Okay, let me check the 7.1 volt at drain of our FET, which should be present here, and we hello, so we only have 620 millivolt present at the drain, where we should have our supply voltage for this amplifier. So there is definitely something wrong. Okay, again let's have a look onto our schematic again. So we see here our 7.1 volt, and we see here the R10, and the R10 is basically coming from the 8 volt line. Let me double check. Yeah, looks like the 8 volt line, and over here our R10 we are supplying over our filter coil our FET. So to be sure that we get our 8 volt line, we should test here in front of our R10, and that will be our next step. Alright, so let's go to R10, which is here, and have a look. So there we have our 8 volt, so we know that the supply is working just fine. And now I go over to the other side of R10 and let's see what we have there. Oops! Hello? Once again 620 millivolt. So that is what we have seen as well at our drain of the FET. I now change over to the drain of the FET once again. I am down there, 620, but we should see 7.1. So what does that mean? So maybe we have here a faulty resistor, or something other is a little bit odd. Let's go down to that test point. Well, but before we run into the wrong direction, I mean, we have seen that we have here 8 volt and here we don't. So where are our 8 volt gone? And we should see the 8 volt, or better set the 7.1 at our drain, which we don't. So before we run into a wrong direction, so let me feed in here, I don't know, somewhere here on the trace, let me feed in a signal, and let's see if Q2, or better said here the trace, that everything is working fine, because if we get a good signal, if we feed it in, let me say here at C16 or C19, I think that doesn't make a big difference. And let's see the behavior of the radio, because you know our 7 volt must be drawn to ground somewhere, because otherwise we would not lose our complete supply voltage here over our R10. So I believe that we have here somewhere you know, a short, obviously to ground, and if the FET would be shorted, then we still have here 100 ohm, where we should then see our voltage. So that is not likely. So I believe we have here somewhere a problem, maybe a short. We have funny capacitors here, so it can't be this one. So that is a C10, and we have here the C11. If the C11 would be shorted, then of course our voltage would completely pulled to ground. So that could be an explanation. But let us feed first here a signal and see what the behavior of our radio is. Okay, and I've prepared here my generator. So you know here my feeding pin here, my feeding device, and we know we have here our Q2. Oh, what is it? Hello? So I don't know if you can hear it. I have not touched anything here. Still not touched anything here. Now I'm touching the C16 and you definitely can hear it. I have a clean signal with -70 dBm. So I'm going here close to, and as I said, not touched. Yeah, I mean, you can clearly hear it, and I can see it on the instrument that I really have a clear, nice, crisp and clear sign. So that is definitely telling me that behind our Q1 here, it seems to be fine. So there must be a problem around our Q1, and let's try to identify that a bit more in depth. Okay, so first of all I try to check our R10 where we had our voltage drop, and our R10 is down here. So let me see what we have here. And we are testing 170 ohm. According our manual, it should be 100 ohm. So I'm testing here in circuit, so you know it is not reliable how I'm testing it, but on the first glance it really looks fine. And yeah, so when I test here from the second end, I mean the end which is connected, if you like, to our FET, and when I then test against the ground, I see only 34 ohm. And remember, our circuit is taken away from our power supply, of course, and 34 ohm here against the ground is definitely not normal, definitely not. Okay, so here is our R10, and so that was looking not too bad, so it is definitely not burnt off and thus open. But when I test from here to ground, I only see 34 ohms. And even we have it here in circuit, it should not read 30 ohms, because in which direction we ever go, so you see here we have a 10K. If we go this way, we have a not 3.3, it is a 33K ohm resistor. And even when we go here over our filter coil, we directly have here our FET, and then another 100 ohm. Well, okay, if we would have a complete short, maybe that then our 185 ohm makes sense. So maybe we really have here maybe a short, but well, you know, I more expect here to have a faulty C. And as only the C11 here is suspect, I would first of all test here this C11 if maybe something is wrong here with our C11. Okay, back here on the board, and well, you see that we have here the C11, and you see that we have some odd solder joints. Remember, when you watch the older video, you see that we took away, I believe it was a dual diode pack which was soldered here over this components for whatever reason. It was a modification. Don't know if it has been done in production or wherever, I don't know. And anyways, we have here our C11, so that is ground point here, okay, and the C11 is of course connected to ground. And let me see what we can test if we go. Here's our R10, and you hear that is our pass to ground with our 30, I don't know, 4 ohm. Still, it could be that, no, not really, because we're only testing 34 volt ohm, and we have seen that the source resistor here from our FET is also, according to our schematic, is 100 ohms, so we should not read 33 ohm, even it is in circuit. So that means, let me, because that is the easiest we can do, let me simply take here our C11 out of the circuit, and let's see what that means to our circuit. Okay, so let me try to get our C11 out of the circuit and around the camera, so I hope it will work. And I use now my camera display as a magnifier. It's a little bit tricky here for me, but I try that you can follow the process. It is a little bit funny here. It is really not a good position to do it. No, I think it is not really working here, so I think I have to do it off camera. So yeah, sorry for that, but I do not really get close enough. I cannot really see what I'm doing here. Oh, come on. Maybe, come on. No. No, sorry. It is not working. Well, and obviously it was working, and that is a proof how badly I can see it here. So our component is really off, and yeah, it is already down here, and I was not really able to see it, and that is really, where is it here? Down on my bench. There it is. So there it is lying here on the bench, and yeah, so and I was not able to really see it. It sticked here to my tweezer, to my hot tweezer, and I was not really able to see it. So anyways, it is off, and we can go ahead with our testing. Okay, unfortunately that was not the case, so I've taken out here our capacitor, the C11, and additional to that I have taken out the C14. So now I still have the problem that I do not have a voltage here at the other side of our resistor, and that now seems to be that we have a shorted FET, which I really was hoping not to have this case, but everything is pointing to that direction, unfortunately. Okay, so on our schematic, once again the C11 is out, so the C11 can't pull down our voltage. Additional to that, I have taken out our C14, because also C14 has a direct pass to ground here over our L4. So that is out, and again that is out, and that means that the only way is over our FET and to gate 1, because gate 1 has again a direct way here to ground. And yeah, as or since I still do not have voltage here at our second end of our R10, I have to assume that our Q1 is internally at least partially shorted, that we see this 30 ohm, which is obviously pulling our supply voltage for the FET to ground, and that means we need a replacement to be absolutely sure that that is a problem. I mean, a front end transistor is always jeopardized, so I do not really wonder that it is this little part, but I really was hoping that it is only, you know, a capacitor, because that would have made it so much easier. But yeah, okay, let's go for the Q1. Okay, whatever we do, we finally need to find where our voltage is lost. So yeah, it is still the same situation at our R10 here. We easily measure our let me do it again. We measure here our 8 volt, and on the other side we only measuring our 17 millivolt, right? So that is up there. So so the only way is to pull here our FET out and see if that will do the trick, that we can finally then test our 8 volt as well on the other side of our resistor. I'm more or less confident that the resistor itself is not high resistance, as we have seen it. I mean, it was a little bit odd result when we tested for, what was it, 160 ohm or so. Anyways, let's simply take out here our little FET and let's see what the result will be then. Alright, and you can see it here. So our Q1 is out. It is laying over there on my solder, right? And now we can do exactly the same test again. Down there we have our R10, and let me see if I can arrange it here somewhat that you can follow me. Oh, let me see if you really can see everything we need. So let's go down here to our R10 to one side. Come on, And yeah, our 8 volt are present. Now let's go to the other side. Come on. And aha! So here we have our 8 volt, and now I can probably test for 7 point. No, it is not 7 point because our FET is out, but at our drain solder point we should test 8 volt as well. And yes, so there it is, right? There it is. And that is now clearly telling us that our little dual gate FET is dead. So we have to replace it. Right, and down there we have our little FET, and for all of you who really want to see if it is shorted out, so let's test here drain and source, and you can hear it, the beeper, that is really shorted out, and therefore, yeah, as said, we have to replace it. Over there we have here our Bose capacitors, which we have taken out to make sure that the short did not come from this Bose, and we identified those as fine. Therefore, of course, we have to put it back into the radio. Okay, so that is now here the working position, and I have fixed the chassis here with my holder, and now I can work here on the PCB to bring back finally here our, where can we find it, there, to bring back here our little capacitors to our circuit. So that is the first step, and then we go and replace, of course, the FET. Okay, so our capacitors are back in there and there, so that is just fine. Now we have to replace our dual gate FET, and yeah, I have here already my cabinet, and I have a replacement tube, which is a NE25139. So that is a very good replacement for what we need. And yeah, let me bring this little dual gate in, and then we are very close and almost ready for testing. Just wanted to show you that the new FET has here one pin which is a little bit bigger than the other pins, and that is a clear indication, according the datasheet, that that is our source pin. So what you really need to do to get it in the right orientation on your PCB, and to put of course your source to source, your drain to drain, and so forth and so forth. Okay, and our new FET is in, so let's go for testing. Okay, so all is connected to the radio. Our generator is sending on 145.52.5, which is the dialed in frequency. And now let's switch on the radio and let's see if it is working. Okay, so let's try. And yes, you can definitely hear it. We are back in business, and what you see, let me switch it here to dummy, and you see we have back here our S meter, And yeah, you may remember when we tested it before troubleshooting, we had to send minus 73 dBm into the radio to get a very noisy signal. And now we are really back to reality. And here we have the figures. So let me go down here with the tone. And you see now I'm feeding minus 90, and we are here on 38 dB Synod, and you can see it over there. We have really a nice and clean signal, so that definitely shows us we are back in business. And of course we are interested in sensitivity right now. And you see I've set here our generator to minus 119, and we are peaking 12, 13 dB Synod, which is quite good. So of course you hear we have a noisy signal. Sensitivity could be a little bit better, but remember we still have our PCB out, and we have here our wire mess. You know, we have all these extended wires here, and of course here we have the IF frequency. Oh no, it's not the IF, so it is really still the HF or RF which is going in, and I mean I'm leading it here over wires and so forth and so forth. So it is no wonder that we do not really achieve a better sensitivity, but I'm quite confident that if we put it back here into the housing, that then we will have an improvement. But even though minus 119 dBm, peaking 13 dB Synod, or maybe a bit more anyways, is already a very good sensitivity, and even we cannot improve it. It is definitely good enough for normal communications. So once again, definitely we are back in business. Well, and I really do not want to bore you, so I really stop the video here. So we really were able to find our problem. We replaced the FET, and now I have to put it back here, the PCB, in the housing, and maybe I do some little adjustments here and there, but in general the radio is back working. So we have fixed our TX problem in video 172, I believe, and now we have fixed here our receiver problem. As I told you already in video 1, it is definitely possible. It is always a question of budget, but as the old man was really wanted to get it back working, so that is what we have done right now. And yeah, that is here definitely the end of the story. Thank you for watching, and catch you next time. Bye.